How's it going, everyone? In this video, we're going to discuss how to calculate cumulative probabilities using the binomial distribution and a cumulative probability table. So here we have an example. A game is played where the probability of success is 0.2. Part A asks, if you play 15 times, what is the probability of winning 4 times or less? So we want the probability that x is less than or equal to 4 given that we make 15 attempts. And we know that the probability of a single success, if you play once, is 0.2. So here we'll use a table, specifically the binomial probability distribution cumulative table, which shows the probability of winning up to and including a certain number of times. So first we want to get the part of the table corresponding to our number of trials, which is in the top corner right here. Now we have 15 trials, so we're going to scroll down until we see n equals 15. There it is. And our probability of success was 0.2, and we want the chances of succeeding up to 4 times, right? 4 times or less. So matching up that row and column gives us the probability 0.8358, right there. 0.8358. So that is going to be equal to 0.8358. Okay, if we were to individually calculate the probability of winning 0 times, plus the probability of winning 1 time, plus the probability of winning 2 times, and 3 times, and 4 times, we would get the same number. The probability of winning 4 times or less. Now part B asks, what's the probability of winning more than 4 times? Well, you could count the probability of winning 5 times, plus the probability of winning 6 times, 7 times, 8 times, and so on, up to 15. But you could use a shortcut. The probability that x is greater than 4, well, that's the same as the probability that x is not less than or equal to 4, which is going to be 1 minus the probability that x is less than or equal to 4, and we already calculated that right here. So it's just going to be 1 minus 0.8358, the number we got from the table here. 0.8358. Subtracting that from 1 gives us 0.1642, right? 1 minus 0.8358 is 0.1642, or in percent form, 16.42%. So there's a 16.42% chance of winning more than 4 times and an 83.58% chance of winning 4 times or less if you play 15 times, and the chances of a single victory during a single play is 0.2. And that's using this table here. So I hope that helps, and until next time.